Aero Engineering Thermodynamics. Basic definition of terms. Adiabatic process is a process during which there is no heat transfer. The word adiabatic comes from the Greek word adiabatos, which means not to be passed. Bar is the unit of pressure equal to 105 Pascal. Bernoulli equation is the result of the energy analysis for the reversible, steady flow of an incompressible liquid through a device that involves no work interaction such as a nozzle or pipe section. For frictionless flow, it states that the sum of the pressure, velocity, and potential energy heads is constant. It is also a form of the conservation of momentum principle for steady flow control volumes. Boiler is basically a large heat exchanger where the heat originating from combustion gases, nuclear reactors, or other sources is transferred to the water essentially at constant pressure. Boiling is the phase change process that occurs at the solid-liquid interface when a liquid is brought into contact with a surface maintained at a temperature sufficiently above the saturation temperature of the liquid. Boundary is the real or imaginary surface that separates the system from its surroundings. The boundary of a system can be fixed or movable. Boundary work (PdB) work is the work associated with the expansion or compression of a gas in a piston cylinder device. Boundary work is the area under the process curve on a PV diagram equal, in magnitude, to the work done during a quasi-equilibrium expansion or compression process of a closed system. Calorie call is the amount of energy in the metric system needed to raise the temperature of 1 gram of water at 15 degrees C by 1 degrees C. Carnot cycle was first proposed in 1824 by French engineer Sadi Carnot. It is composed of 4 reversible processes, 2 isothermal and 2 adiabatic, and can be executed either in a closed or a steady flow system. Carnot efficiency is the highest efficiency the heat engine can have when operating between the 2 thermal energy reservoirs at temperatures TL and TH. Carnot heat engine is the theoretical heat engine that operates on the Carnot cycle. Carnot heat pump is a heat pump that operates on the reversed Carnot cycle. When operating between the 2 thermal energy reservoirs at temperatures TL and TH, the Carnot heat pump can have a coefficient of performance of. Carnot principles are 2 conclusions that pertain to the thermal efficiency of reversible and irreversible, i.e., actual heat engines, and are expressed as follows. 1. The efficiency of an irreversible heat engine is always less than the efficiency of the reversible one operating between the same 2 reservoirs. 2. The efficiencies of all reversible heat engines operating between the same 2 reservoirs are the same. Carnot refrigerator is a refrigerator that operates on the reversed Carnot cycle. When operating between the 2 thermal energy reservoirs at temperatures TL and TH, the Carnot refrigerator can have a coefficient of performance of. Classical thermodynamics is the macroscopic approach to the study of thermodynamics that does not require knowledge of the behavior of individual particles. Clausius inequality, first stated by the German physicist R.J.E. Clausius 1822–1888, is expressed as the cyclic integral of dq/t is always less than or equal to 0. This inequality is valid for all cycles, reversible or irreversible. Clausius' statement of the second law is expressed as follows. It is impossible to construct a device that operates in a cycle and produces no effect other than the transfer of heat from a lower temperature body to a higher temperature body. Closed system consists of a fixed amount of mass-controlled mass and no mass can cross its boundary. But energy, in the form of heat or work, can cross the boundary. Coefficient of performance (COP) is the measure of performance of refrigerators and heat pumps. It is expressed in terms of the desired result for each device: heat absorbed from the refrigerated space for the refrigerator or heat added to the hot space by the heat pump divided by the input, the energy expended to accomplish the energy transfer, usually work input. Conservation of energy principle states that during an interaction, energy can change from one form to another but the total amount of energy remains constant. That is, energy cannot be created or destroyed. First law of thermodynamics. Control surface is the boundary of a control volume, and it can be real or imaginary. control volume open system is any arbitrary region in space through which mass and energy can pass across the boundary. Most control volumes have fixed boundaries and thus do not involve any moving boundaries. A controlled volume may also involve heat and work interactions just as a closed system, in addition to mass interaction. Cycle is a process, or series of processes, that allows a system to undergo state changes and returns the system to the initial state at the end of the process. That is, for a cycle the initial and final states are identical. Efficiency is defined as the ratio of desired result for an event to the input required to accomplish the event. Efficiency is one of the most frequently used terms in thermodynamics, and it indicates how well an energy conversion or transfer process is accomplished. Enthalpy H from the Greek word enthalpy N, which means to heat, is a property and is defined as the sum of the internal energy U and the PV product. Entropy from a classical thermodynamics point of view is a property designated S and is defined as ds equals dq/d in ref. Entropy from a statistical thermodynamics point of view can be viewed as a measure of molecular disorder, or molecular randomness. The entropy of a system is related to the total number of possible microscopic states of that system, called thermodynamic probability P, by the Boltzmann relation, expressed as S equals KLNP, where K is the Boltzmann constant. Equation of state is any equation that relates the pressure, temperature, and specific volume of a substance. Property relations that involve other properties of a substance at equilibrium states are also referred to as equations of state. Equilibrium implies a state of balance. In an equilibrium state there are no unbalanced potentials or driving forces within the system. The system in equilibrium experiences no changes when it is isolated from its surroundings. Extensive properties are those whose values depend on the size or extent of the system. Mass m, volume v, and total energy E are some examples of extensive properties. Extensive properties of a non-reacting ideal or real gas mixture are obtained by just adding the contributions of each component of the mixture. First law of thermodynamics is simply a statement of the conservation of energy principle, and it asserts that total energy is a thermodynamic property. Chowell's experiments indicate the following. For all adiabatic processes between two specified states of a closed system, the net work done is the same regardless of the nature of the closed system and the details of the process. It may be expressed as follows. Energy can be neither created nor destroyed, it can only change forms. The net change, increase or decrease in the total energy of the system during a process, is equal to the difference between the total energy entering and the total energy leaving the system during that process. The energy balance can be written explicitly as first law of thermodynamics for a closed system using the classical thermodynamic sign convention is Q net in W and ET about equals E system or Q. W equals E, where Q equals Q net in equals kin. Out is the net heat input and W equals W and ET about equals Wout. Win is the net work output. Obtaining the negative quantity for Q or W simply means that the assumed direction for that quantity is wrong and should be reversed. Formal sign convention. Classical thermodynamic sign convention for heat and work interactions is as follows. Heat transfer to a system and work done by a system are positive. Heat transfer from a system and work done on a system are negative. Gauge pressure is the difference between the absolute pressure and the local atmospheric pressure. Gas constant R is different for each gas and is determined from R equals ruthenium/m. Geothermal heat pumps, also called ground source heat pumps, use the ground as the heat source. Heat engines are devices designed for the purpose of converting other forms of energy, usually in the form of heat, to work. Heat engines differ considerably from one another, but all can be characterized by the following. 1. They receive heat from a high-temperature source, solar energy, oil furnace, nuclear reactor, etc. 2. They convert part of this heat to work, usually in the form of a rotating shaft. 3. They reject the remaining waste heat to a low temperature sink the atmosphere, rivers, etc. 4. They operate on a cycle. Heat pump is a cyclic device which operates on the refrigeration cycle and discharges energy to a heated space to maintain the heated space at a high temperature. It is a cyclic device which causes the transfer of heat from a low temperature region to a high temperature region. Heat pump coefficient of performance is the efficiency of a heat pump, denoted by COPHP, and expressed as desired output divided by required input, or COPHP equals QH/W and ET. Heat reservoir is a thermal energy reservoir since it can supply or absorb energy in the form of heat. Heat sink is a heat reservoir that absorbs energy in the form of heat. Heat source is a heat reservoir that supplies energy in the form of heat. The ideal cycle is an actual cycle stripped of all the internal irreversibilities and complexities. The ideal cycle resembles the actual cycle closely but is made up totally of internal irreversible processes. The ideal gas is a gas that obeys the ideal gas equation of state. The ideal gas equation of state or ideal gas relation predicts the PVT behavior of a gas quite accurately within some properly selected region where PV equals root